In this lecture, we're going to learn about default arguments with function templates. And we're going to look at a simple example to really drive this home. Here we have a function template. The function name is maximum, as you see here. And the return type is a template parameter we have declared on top here. We have two parameters in this function. And all of these parameters are declared on top here. You see P, T here, and we have the return type specified first, but we have a default value for this return type here. And if we don't specify it, it's going to be double by default. So if we declare a function like this, we can even call this function without specifying any explicit template argument, and it is going to compile because the compiler now knows that if you don't have a template argument n, it's going to just use double as the default. Another way we can do this, we can put the return type last, for example, and we're going to put in our default like we do here. But you have to remember to really respect the rules here. If you just specify a few parameters, the compiler is just going to deduce the others either based on the default values that we have in here or from the parameters that you use to call the function here. And with this way of doing things, we have the flexibility to split our code into function declaration and function definition. And this is going to work because we really are not doing any return type deduction here. Okay, here are a few examples of how we can call these functions, and we see the output that we expect. The maximum function has the return type as the first parameter, and it is using a default argument. So if we call this is going to deduce the return type to be double. And that's what we're going to get here. For the second pair of examples here, we are specifying one explicit template argument. And this is going to be our return type because it is the first argument here. The others are going to be deduced from the arguments that we pass here. And this is going to deduce int because that's our return type in here. The third one is going to call the minimum function, and you see we are specifying all the arguments. So the return type is specified last, if you remember. So we're going to use int as our return type here, and that's what we're going to see if we print this out. Okay, now that you know this, we're going to head over to Visual Studio Code and play with this a little more. Okay, here we are in our working folder. The current project is default arguments. We're going to grab our template files, put them in place here, and we're going to open this in Visual Studio Code by dragging and dropping on top of Visual Studio Code like this. And we're going to have our main CPP file. We're going to close the left pane here. We don't want that. And we're going to clean up a little bit. The first thing we're going to do is to put in our maximum function, and we have our return type here, but we're going to use a default, and we're going to say equals double. This is going to make the return type be double by default. Once we do this, we can call this function without really specifying the return type here, and it is this simple. So for example, we can go in main and set up two variables like we are doing in this course here, and we are going to say double, for example, and say b and put in 9.5. Why not? And then we're going to say auto result, and we're going to say maximum A and B. And now the return type is going to be the default here. Remember, by default, the compiler can't really deduce the return type. It can't figure that out by itself. Let's take out the default here and show you the compiler error. We have seen this before, but I am going to show this again. The problems tab is going to say no instance of function template maximum matches the argument list. We are passing in int double, and the problem really is the compiler can't figure out the return type. It has no mechanism to really help it out. And before we have seen that we can use explicit arguments to help the compiler out. For example, we can say double here, and you're going to see that this is going to compile. Now the compiler knows that it can turn the return type into double here because this is what we specify. This is our explicit template argument. But this is not what we are interested in this lecture. What we want to see is how we can use default arguments in our function templates to help the compiler out. And this is really going to be an alternative way to have this code here compile. So we can go on top and specify the default for the return type to be double. And now you're going to see that the code is going to compile. The compiler is going to look at this and say, I don't know how to deduce my return type. And it's going to say, is there any other way I can figure this out? And it's going to look at the template statement here, and it's going to say, I have a default value here for the return type. So that's what I'm going to use here. I am going to return double from this function, and this is going to compile. If we try to print out the return value here, so let's do that. You can see this, we are learning. Don't be afraid to try things out. So we're going to print result here, and we're going to print its size like we always do. Okay, we have this in place. If we compile this, we're going to see that it is going to work. And we're going to be returning double from the function here because that's what we specified by default here. This is how you can use default arguments to really do things in your C++ applications with templates. If we run this, we're going to get whichever is the maximum between these two, and the return type is going to be of type double because it is the default here. Okay, now that we have this in place, you can really set up the function call like you want. You can use explicit arguments. For example, you can specify only one argument. This is going to compile, so this is basically going to override the default here, and it's going to make that double, but they're going to be the same. But if you want, you can make this an int. Let's see what we get if we make this an int. Which one is going to take precedence between the default value and the explicit template argument here? Let's see. Let's run this and really figure this out. The build is good, so we can clear and run Rooster. You see that the return type now is int because the size of that is 4 bytes in memory. So the explicit template argument here won over the default argument that we had. But if you want, you can even specify multiple parameters for this template parameters here. So what I mean is, for example, say double. And now the compiler is going to deduce T and P to be double and double because these are the template arguments we pass. Okay, let's try and build and see that this really works. So what is going to happen is, let's run this first. You're going to see that the result is a 9. What is going to happen is the compiler is going to see the return type of this function is int. The first parameter, which is T here, is going to be double. The second one is going to be double. That's what the function takes. But what we are passing in for the first parameter is an integer. So the compiler is going to do a widening implicit conversion from int to double, and then it's going to pass that by value into this function template instance here, which is going to have these types. So we are going to compute the maximum in the body of the function here, and because our parameters or arguments are of double type, the result of this expression is going to be double. And after we have this computed, the compiler is going to see that we have an int return type. And it is going to do another conversion from the double that we have here to the int that we are returning here. And that's why we are printing the result 9 and chopping off the decimal point here, because we are basically doing a narrowing conversion when we return from this function here. I really want you to see this. Okay, if we want, we can also put in 2 parameters. You really have to play with this a little more to be able to see what is happening. In this case, the compiler is going to deduce the type of the third template parameter based on what we pass to the function here by calling it. And P is our second parameter here, and it is going to be of double type. So that's what the compiler is going to deduce, and it is going to use that in this expression here. Okay, now that we have seen this, let's put in another simple example, which is going to compute the minimum between A and B. Notice the expression here to return. It is saying if A is less than B, then A is the minimum. We return that. If A is not less than B, then B must be the minimum. We're going to return that. And notice that our return type now is specified last. But because it has a default, we can completely not put in explicit template arguments, and this is going to work. So let's change our call here to minimum and really use this. So we're going to use minimum. We're going to try and not specify any template argument. and see if this works and compiles. So we're going to compile this with GCC. We expect this to work because the default is specified for the return type here. So this is going to work. The return type is going to be double by default, and we're going to print that 6, and the size is going to be 8 in memory. I think we compiled this, but let's do that again just to be sure. So we're going to clear and run rooster. Result is 6, and the size of the return type is 8. So we are using the default return type here, which is double. But we can specify our own template arguments. So if, for example, we say int here, this is going to be in the placeholder for t. So this is going to be our first template parameter here, and this is going to be the argument we pass when we call the function. So the first guy here is going to be forced to be an int. Even if we pass double like this, for example, the compiler is going to convert the argument that we pass to int, because the first parameter here is forced to be an int by this template argument we pass here. Okay, we have this in. Let's try and build and see what we get. The build is good. We can clear and run rooster. We're going to get basically the same thing. But we can also put in 2 template parameters, or template arguments, I should say. For example, let's say double. So the second guy for p here is going to be double, and that's what we expect. So double for the second parameter is n. We're going to put these guys in. We're going to do the expression here because a is int and b is double. The result of this expression is going to be double. But our return type is double because of the default here. So we're going to return double, and we're not going to do any conversion. This is going to return directly, and the return type is going to be double, and we're going to see size of result to be 8 here. Let's build again. The build is good. We can clear and run rooster here, and we see exactly what we expect here. We can even specify a third parameter, and let's change this to int. And again, this is going to override the default for the return type here and make that int. So even if we have int and double for t and p here, they are going to be used in this expression here, and the expression is going to return double because that's the largest type between a and b. We're going to return this, but the return type is going to be int. So we're going to do a narrowing conversion from double to int. We're going to assign that to result. So we're going to deduce int here. We're going to print this guy, and this is going to print 4 because that's our type here. Let's build and see that this is the case. You really need to understand these things. And once you understand them, you're no longer going to have problems with these kinds of things. So the type is what we expect here. Size of result is 4, and the return type is really int here. This is really all we set out to do in this lecture, showing you how you can use default arguments to simplify your function templates. If you think this is going to be useful for your project, please go ahead and take advantage of this. For now, we're going to stop here in this lecture. In the next one, we're going to learn about non-type template parameters, because what we have been using so far in this chapter are type template parameters. For example, our template parameters were things like double, int, and whatever. Now, starting in the next lecture, we're going to see that we can even use non-type template parameters. And we're going to see what this exactly means in the next lecture. Go ahead and finish up here and meet me there.